Hi, I'm Sven. You can follow me on Twitter if you want on the handle. I do speak French if you want to, and I'm based in London now. I work for a company called Cloudflare. If I say something bad during the talk, views are my own, not Cloudflare's. So the plan for today's talk is that I will show you a bit of how the ecosystem looks like, what platform and language you can use to use WebAssembly today, and the state of the art of WebAssembly, and quite some ongoing work to improve how things. So first, let's start with something simple. What is WebAssembly, or WASM in short? So it's a way to take any programming language and run it into the browser. There's a quote I found on a blog post that I link below. I think it's cool, but I don't think it's quite accurate because it doesn't target only the browser. Many environments like the cloud, where you have, for example, Fastlane Cloudflare are both serverless provider that allows you to run a WebAssembly module on requests to transform it or to actually respond to those requests. This is a fun one, I think, because if you know Kubernetes, instead of running Docker container, you can run WASM modules using something called Cruiselet. This shows you how far you can go with WebAssembly, I think. Embedded device is also a good target for WebAssembly because WebAssembly instruction set is pretty small and pretty well defined. It's easy to implement, and usually implementation have pretty low memory and runtime footprint, which makes it very suitable for small devices like an Arduino board. Also, your program could be its own WebAssembly host. So for example, you might want to, so you have multiple libraries in many languages where you can use WebAssembly modules in your program, run WebAssembly modules in your program. And you might want to do this to run untrusted user code, such as like a plugin system, where you want your user to write a plugin for your application in any language they want, and you can just run it and in a safe way, I guess. So for example, if running WebAssembly in PHP is your thing, there's a library that I linked down below that you can use. And in my example, I'm just using a sum function that sums two numbers, and you will get the result back in PHP. Also, you have a couple of standalone implementations. So I mentioned two, WasmTime and Wasmer. Both are CLI tools that you can use. So given that you have so many platforms, and you might want to run your one WebAssembly modules on multiple platforms, for instance, to test your code or to reuse some code. So you need a way to ensure that the module actually runs on multiple platforms. And as a reminder, WebAssembly is like a sandbox by design. WebAssembly itself doesn't have the power to touch the outside world. It does only by using the help of the host. So when you have a WebAssembly module, when you want to run it, you need to import functions or value from the host. And the host can call WebAssembly functions that are exported. So WebAssembly needs to ask the host to open a new network connection, for example, or needs to ask the host to open a file to read it. But if the host doesn't provide anything, WebAssembly won't do anything. It's by design. So given that, and you want to use the code across multiple platforms, you need a way to have a common interface. Something like POSIX that allows you to open new connections and read files and do what you want. Note that if you use WebAssembly in your program and run WebAssembly modules more manually, I guess, you can invent your own interface, but people will have to give you modules that comply to this interface. but that's up to you. So WASI is a thing that Mozilla made. It stands for WebAssembly System Interface. And it's exactly that. So WASI provides access to operating system features like files and a file system, opening connections, access to clocks, and any numbers or any kind of system operations things. So as an example, here's a small diagram where in the middle you have the WebAssembly WASI implementation, and your app sits on top of it and use it. And it abstracts away all the operating system stuff. So underneath, you could have anything that implements WASI, so an OS or so even if WASI doesn't run in the browser, you have a web polyfill that allows you to run WASI module using JavaScript in the browser. So if you really need that. So in terms of usage, multiple languages support WASI, such as Rust. If you install Cargo WASI, you can use that to build your Rust program and compile it to WASI, to WebAssembly module that implements WASI. And then you can use a standalone implementation, for example, wasm-time, to run this module. And this app is pretty simple. We just print hello. Similarly, with C and C++, you could just create your Hello World application and compile it and run it the same way. The setup is a bit more complicated, and I was too lazy to do it, so I didn't do it. But essentially, it's the same thing. So WASI is still new, so you don't have a lot of platform that supports it at the moment. Node.js is another solid implementation, but as time goes, you will have much more choice in the future. So there's also something quite funny, I think. So there's a tweet of one of the founder of or co-founder of Docker that says that if WebAssembly and WASI existed at that time, you wouldn't need to create Docker. It would just WASI and WebAssembly would be an enough container or sandbox system where WASI will be the interface to the operating system. So I think that quite shows you how you can think of WebAssembly. So not many languages compared to WebAssembly and WASI at the moment. I showed you Rust and C++, but you have a couple of more, but not that much, I think. But many languages compared to WebAssembly itself. So I have a quick list, but if you click on the link below, you have much more languages. So I talked about interaction between WebAssembly and the operating system, but I didn't really talk about interaction between WASM and the host it's running on. So for example, if you want the host to call WebAssembly functions or WebAssembly to import host things, you need a way to have like a type system and passing values and stuff like this. So here's a quick look of WebAssembly's type system, which at first is a bit limited. So you only have 4 basic types, which are 2 floats and 2 ints, both 32 and 64 bits. So now you might be wondering, if you have such a restricted type system, how can you access things like host objects? So if you run into a web browser, how can you get access to the DOM? Or how can you just like pass strings between the host and WebAssembly? So you have a couple of answers. One of them is just tooling. So we already mentioned this, I think, a couple of times. ECMAScript N is a way to run C, to compile C and C++ to WebAssembly and have some help to interact with JavaScript. So for example, you can emulate an entire file system. So from the C and C++ point of view, you could just talk to the file system as you would natively, but it would just be something emulated that runs in a browser or just in a cloud or something. You can also get access to I/O. So here's a quick example where I have my program with a main function that calls my.js function. That function is externally defined in JavaScript. in the my.js function, I can pass it a string. And I will talk more about this later, but this is just an example of how ECMAScript 10 works. So I mean, it's just C and C++. Similarly, ECMAScript 10 compiles down a subset of TypeScript to WebAssembly. So again, I have a function that returns a string, and I return a string. You can compile this and run it, and run what you want. Again, same thing. WasmBindGen is a way to compile Rust to WebAssembly and have a good way to interact with JavaScript. So everything that is annotated with WasmBindGen is an import from JavaScript and export to JavaScript. So I'm importing on the top, you have an import from the alert JavaScript function, and on the bottom you have an export to JavaScript. So in JavaScript you can call greet, which will call alert, which will pop up the alert thing in your browser using the string I passed. So I'll show you a couple of examples of languages that use strings between WebAssembly and the host. But I said that WebAssembly type system doesn't allow that. And the reason is that we have something called glue code. So it's something that is running on the host. It's just code running on the host that is usually generated by the tool, or it's runtime that the tool embeds. And it's used to convert values between WebAssembly and the host. So typically, you can convert a string from WebAssembly to the host. And as an example, it's kind of done this way, where the WebAssembly module can expose its memory to the host, such that the glue code can just read the memory as it wants. And if the user wants a string, so for example, if you run in Python, it will be just a Python string. And the glue code will read the bytes in the WebAssembly memory and just extract the string and pass it to the user. And it's specific to the language because the glue code needs to assume how the type looks like in memory. So I guess it's working. It's working pretty well if you use the tools. If you have a language that doesn't support such great tools, then you need to do it yourself. And it's quite a pain, I guess. And ideally, just be built into WebAssembly. So now I'm going to start showing you a bit of the ongoing work that WebAssembly Community Group is doing. So the first one is phase 4, which is very close to shipping into the phase process. And I think it's a good start because it allows WASM to hold data that the host has. So if you are into a browser, WebAssembly could hold a DOM reference, but WebAssembly doesn't know what the reference points to. It's pretty opaque to WebAssembly, but at least WebAssembly can use it to store it or to pass it to other functions. If the function that the WebAssembly passes it to turns out to be a host function, it will be like the same value that the host provided in the first place. So it allows you to do things like this. If you have a WebAssembly module where you have a function that just takes whatever the host gives and just returns it, on the host, you can call it using an object like a string, and you will just get back the string again. And this is not very advanced, I guess, but it's allowing you to remove all the glue code that you need just to pass like complex objects between WebAssembly and the host. It's an improvement, but it doesn't allow WebAssembly to touch those values. As I said, it's opaque to WebAssembly. It doesn't know what it points to. And the only way you have to modify the string, for example, that you pass to WebAssembly is WebAssembly calling to the host again, passing that string. This is why you have another proposal built on top of that, which is called interface type. This is a pretty recent one in the WebAssembly process. So it will take some time, but it's coming. So if you take my same example of a function that gets a string and returns a string, you could have some flow like this where, so I didn't mention this, but interface types defines what we call adapter functions, which is basically, instead of having the glue code running on the host, it's WebAssembly instructions doing the conversions. So on the diagram below, if you take my same example of function returning, getting a string, returning a string, it gets the host string, transform it to a WebAssembly string, which is, if you compile it from Rust to WebAssembly, it will just be a Rust string. You can do whatever you want with that string, and then you can return it to the host again. And this allows the WebAssembly, whatever language you used, to do operations on that string. So I think that's pretty cool. Another aspect of the proposal is something called WebIDL integration, where WebIDL is some kind of language we use to describe web APIs in terms of types. And so the idea is that you can use that language to automatically generate adapter functions, which means that WebAssembly could actually call web APIs directly using the right types with no glued code at all. So I think that's a pretty good improvement now. So the last point of this proposal is that it talks a bit about module linking. So if you're familiar with native module linking, you can just like link things together. So if you have a program and a library, you can statically link them together or dynamically. WebAssembly already has support for dynamic linking, where you could use the exports of one WebAssembly module and feed it into the imports of another WebAssembly module. And this is all at runtime. But in that case, you need to agree on the type representation of both WebAssembly modules. And you maybe don't want to do that. So if you do it today, it will look like a bit like this. So on the left, I have my WebAssembly application, where on the right, I'm using some library. And my WebAssembly exposes the memory to the host. And when I call my library, some function, and the library is supposed to return me a structure or an object, something, it will actually need to edit my WebAssembly memory, my program memory, in order to fit in the structure so I can read it back. So I guess this is cool when you own all the code, but if you're using a random library on NPM or something, it's pretty unsafe to do, I think. So the proposal introduced the concept of shared nothing linking, where ideally you don't share anything. So you have multiple modules. Imagine multiple modules with multiple languages that use multiple type representation. And what you want in that case is something like this. The same example, I have my WASM application that uses a library, and it doesn't share the memory, it doesn't share any code, it doesn't share anything, in fact. So when I call this library, and this library returns me an object or a string or a struct, it will actually send me just bytes. And the WebAssembly engine will copy these bytes into my memory for me. And using interface types, I will have these adapter functions running before I get the bytes, on the bytes, sorry, to lift the bytes to any structure I decided. That way you don't need to share anything. It will just lift the bytes for you. And another pain point is that garbage collection is not built into WebAssembly. So languages that rely on garbage collections have a bit of a hard time to compile down to WebAssembly. I mentioned a lot Rust and C++ and C and assembly script because they don't necessarily rely on any garbage collection. So it's a pretty good candidate for compiling to WebAssembly. But if you use Go, on the other hand, it needs to compile its GC garbage collector into the module in order to actually have a garbage collection at runtime. It can be okay, but it adds some size to the module. So if you run into a small environment, you will actually be add up the size, which you don't want. And ideally, GC is something that is built in that any language can use. So this is also something that's being worked on in the WebAssembly Community Group. It's a big proposal, so it's fairly new, so you can expect it will take some time, but at least it's coming. So on the more browser side, I guess, something I really like is that you have a way to import your WebAssembly module as you would import your JavaScript module. So if you use the new fancy syntax on the first line, you can import your WebAssembly module, and you can actually grab a function out of it and directly call it. I think that is quite clean. And the big picture of this is that ideally you have your JavaScript application with a JavaScript entry point, and then you can import any JavaScript module or any WebAssembly module. And the WebAssembly module could be written in C, C++. It could be on the package manager npm. At that point, WebAssembly is just an implementation detail. You just import whatever module, and if it turns out to be WebAssembly, you can run it. And I think this could be applied to many different languages, and it's quite useful if you want to ship WebAssembly modules in the language package manager, such that you can reuse it on the community. So for JavaScript specifically, this is called ECMAScripted module integration. It's currently phase 2. It's also something that is being worked on. So I'm mentioning WebAssembly Community Group quite a lot. It's the space where proposal can involve and being worked on. And you maybe notice that community is in the name. And it's on purpose because anyone can just show up and contribute to any proposal they want. There are bi-weekly calls that you can join to just chat, I guess. You can also like jump into GitHub issues and discuss about stuff. And people are really looking for feedback there. So if you want to contribute and add your feature or discuss about your use case, I think that's a good start to get started into WebAssembly. Okay, so that's it for me.